Excellent. Hey, thanks everyone for sticking around for the last session. We're going to have a lot of fun here. How many of you have a software supply chain? Raise your hands. Okay. Well, the reality is you all have a software supply chain. So I'll give you a choice. I think you might be familiar with that choice. You can take the blue pill, and the story ends. You can walk out and leave, and you wake up in your bed tomorrow and everything's fine. Or you take the red pill, and you end up in staying in Wonderland, and we see how far this rabbit hole goes, I think is how it goes. So for those of you that were blue pillars, survival is not mandatory. If we're going to talk about DevOps, if we're going to talk about velocity, rapid releases, the ability to maintain sanity, we have to bring in Deming, the patron saint of DevOps here. But I'm going to start this journey in, of all places, the most innovative mecca on earth, and that's Detroit. So in Detroit and in other large manufacturing industries or places of manufacturing industries, you have massive supply chains that produce a massive volume of products at extremely high velocity with tremendous quality. And that is because they've looked at their supply chains to make sure that what they're bringing into their products is of the highest quality parts. They are sourcing those from the highest quality suppliers and the fewest suppliers that they have. And the traceability and visibility to those parts across the supply chain is extremely clear. So Dinah talked about this before, this traceability, visibility. What are we bringing in? Where do we know it's going across our release train is extremely important at Google, and it is in these organizations as well. And whether you're developing toys, cars, pharmaceuticals, food products, what have you, you name it, you have a supply chain that operates with these principles and operates very well with these principles. And that's in order to help these organizations really build quality in. This is a key motto of Deming and of DevOps, to start with the highest quality things to build them in first. To use that to help reduce the complexity and the variability within the organizations, but also to make sure that things go as smoothly as possible. And then we want to version everything within these environments so we know exactly what parts were used where. So if we need to roll back to anything or recall anything, we know exactly what that is and how and where it went. And these supply chains are so sophisticated that every nut, every bolt used within these vehicles, every ingredient used within the pharmaceuticals or toys or food products, what have you, and they know where it is, because if something goes wrong, they want to be able to find it and replace it and roll that back quickly. So, my name is Derek Weeks. I work at Sonatype, and I had the privilege of researching earlier this year over 100,000 software development organizations and how they work. Because of our central role at Sonatype, it's a company you probably haven't heard of unless you're a Java developer, and then everyone probably has used our tools. We run the Maven Central Repository. It's the largest open source repository on the planet, and I'll tell you a little more about that later. We serve over 9 million developers. Our founder built the Maven build tool. We also have Nexus repositories and a bunch of other things. But that's allowed me some visibility into these organizations to show you how they behave. And whereas other supply chains in other industries behave in very predictable ways to ensure they're delivering the best things at the highest velocity, at the highest quality, software doesn't behave that way. And so I'm going to shed a little light on that through the conversation today. I'm going to walk through the software supply chain to show you what my research showed you, And some of it will be somewhat of a wake-up call. Some of you will not be surprised by this. Some of you will say, my organization looks and behaves probably exactly like this. Some of you, like this morning's talk with Christopher, may leave here worried that we're all doing the wrong things and we have bad software out there and we're completely attackable and all of those things. But the reason that I did this was we had the visibility within Sonatype on what was happening in this gigantic ecosystem that we're going to talk about that operates at huge velocity and tremendous volume. And I wanted to share that information because sharing the information allows us as a community to figure out how to improve what's going on within our software supply chain so that we can operate better. So let's figure out new ways that we can operate in a better sense. So the big thing that's happened in the last couple of years, or really decade or decade plus, with software is that software development has changed dramatically in terms of the use of open source being brought into our products and used to assemble our products. But our processes around it have not changed enough. And we can actually benefit tremendously from this. And those that figure out how to benefit from it and what's going on and how to use it will be the winners and losers within within software and within the technology fields. Gene Kim, are all of you familiar with him in the Phoenix project? He was one of the guys that helped me review this particular report. John Willis, who's also spoken here, was one of the early reviewers in Puppet Labs and Disney as well. If you haven't read the Phoenix project, stop now, you're online, go to Amazon or wherever you want, order that book, buy it, absolutely read it. It will totally change the way you think about what you do on a daily basis. But one of the things to give you some visibility into the world that I see on a daily basis, open source components that help us build our software today are used in a gigantic sense. And that in the last 7 years or 8 years, the volume of consumption has grown 30-fold. We handled 17 billion download requests last year from the central repository. My mom does not use the central repository. She's not a developer, right? But there are 11 million developers in the world that do this. And this is just Java open source components. This is, again, giving you the sense of what the volume of consumption is out there within the universe. But it's not simply open source components that are being consumed from these public repositories like Maven Central or rubygems.org or pypy.org. It's also things like the Google Image Registry, the Docker Hub, what have you. Whereas we handled billions of open source component downloads across the industry, Docker, I think just this summer at DockerCon, said that they had over 500 million pulls from Docker Hub of different images out there. The volume of what is being consumed to allow us to be more innovative and faster and improve our velocity is extremely high. To give you a better sense of how this is impacting our daily world, question for you, quick question. Out of a modern application, what % of it is now composed of open source components? A, raise your hands. B, raise your hands. C, raise your hands. Okay, you guys are actually more in tune than other audiences I talk to. C is the answer. So about 80 or 90% of a modern application is composed of open source components. And why? Because it makes us go faster. Why in the heck would I want to develop something from scratch when I can just go out to the internet and get it, put it into my application, and we can ship it? It's going to save me so much time. I can meet my time to market pressures, right? Everyone's using that particular component. It's popular. It's been popular for a while. It does what it does. I've used this since I was in high school, kind of component or binary or library that I need. But it's dramatically improving the way we build software. It's making us faster. And if we pick the highest quality parts from the best and fewest suppliers out there, just like the auto industries and pharmaceutical and others are doing, we can dramatically improve the reliability and availability of our systems. But let me tell you a little bit about the ecosystem that, as we see it. In Maven Central, we currently house, and this slide is always outdated because the numbers go up by hundreds or thousands each day. We house 1.1 million open source components. Those are what we received the billions of download requests for last year. We see 120,000 open source projects that are supplying those open source components to us, updating those 3 or 4 times a year that are coming in. And those components are freely available to anyone that wants to download them and bring them into their organization. So in software development, right, you're not using, in your organization, in your company, you're not relying on 120,000 different suppliers or a couple of 100,000 different suppliers of these components or even images, if you look at images or containers that you would be consuming. So just quick poll of hands again. How many suppliers do you think your organization on average is dealing with each year? A. Show of hands. B. Show of hands. C. Okay, so it was kind of evenly dispersed throughout there, right? So it's one of these answers, but let me tell you a little more about the answers. So if you look at Toyota, do you know how many suppliers they have? 225. It's actually in the hundreds somewhere, in the low hundreds, right? If you look at someone like Ford, right, or Chrysler, they have about 5,000 suppliers within their organizations. In the average development organization, we saw they were using 7,600 different open source projects they were relying on, which basically means on 7,600 different occasions, or if you include all the versions of those projects, 18,000 different occasions, they decided I don't need to build that myself. I will outsource that by going out to the internet and getting that component so I don't have to build that component from scratch, right? There is a massive amount of complexity and variability in this. And they weren't just downloading the part once and storing it locally where it could be reused. They actually said, you know, I like downloading so much, I'm going to download these things like 10 or 100 times into my organization because that makes me a little more efficient. When you think about OpenSSL, Bash, Poodle, Shell Shock, all of these other different components that came out with vulnerabilities last year, you see an article every time one of these comes out. Actually, you see like 8 in this same week of a new vulnerability. And there's a major vulnerability just announced this week in the Commons application or the Commons component. The article that mentions with many eyeballs, all bugs are shallow. Everyone's heard of that, right? Open source is a lot safer, a lot more secure than closed source software. So we see 120,000 different open source projects. And what we found is when those projects had a vulnerability in the component or one of its dependencies, 59% of the time it was never repaired. That means the project, even though it released 3 or 4 more versions each year since that was released, they never fixed the security vulnerability that was open, has a CVE assigned to it, never fixed. When it was fixed, the average mean time to repair was 390 days. This does not include the time that it takes you to get this particular component into the software that's running in production in your organization, right? And that's part of that is because there's no communication between the open source projects and the people that have actually consumed those projects and are using them. So they can't effectively see who's using it and recall those components. It's not just Java. There's a great source, modulecounts.com, that has, you can see the growth of all the different open source projects, how many components they have within the repositories over time. The biggest repositories like Maven Central are serving billions of downloads. Even the newbies like Bentray or the NuGet Gallery, these guys are doing 250 million downloads a year. Again, there are only, according to IDC, there are only about 11 million developers on the planet that would even care to get stuff from these repositories. So there's a communication link that's broken between these projects and the developers that are consuming them. But there are ways that we can go about managing this process in a much better way. So when I looked at the downloads, there are different ways that you can download these components from these repositories. And whether that's an open source component for Java or Python or Ruby, or you're looking at Docker Hub or Google Image Registry, any of these components will follow the same path. You can go directly to the public repo and download them to your build tools or your desktop or whatever tool that you're using. Your release tools can go and get these images directly from the internet. Or you can take a more efficient route and download them with a repo, use a proxy to get these components, and then have those proxies feed the rest of your organization. So the basic comparison is, you know, I like strawberries, right? And I only go to the fields once a year and pick my strawberries with my kids. So I spend a couple hours on the ground digging up strawberries and putting them in their basket, and the kids spend like an hour stuffing their faces with strawberries and all of that. But I only go to the field once a year, right? I don't go all the way out to the public repo. I go to the grocery store to get my strawberries, if you will, because it's more efficient, right? And if I did this in software development, my builds would run faster. To give you a sense of how many people follow version 1 or pattern 1 versus pattern 2, anyone want to throw out a guess on pattern 1? What percentage of the downloads it represents? Vast majority. 80-something? Okay. So it actually represents 95% of the downloads. Go directly from some build tool, right, directly to the public repos, right? And 5% represents this proxy that can go and just get the components that aren't needed. So the parts are stored locally, and they're a lot faster to retrieve. The builds run faster, the releases run faster that require these particular components. But what this means in the software supply chain context is we have a huge number of people in procurement. How many developers do you have in your organization? 10, 100, 200, 2,000, 4,000, right? Keep going, right? How many people do you have in software procurement? 10, 100, 2,000, 4,000, whatever, right? The same number of people you have in development is the same number of people you have in procurement within your organizations. Whereas other supply chains have a place to vet, even for things like hardware or other things that you buy in your organizations, there is a procurement department that says, we're going to figure out the best stuff from the best people and source that, and we're going to keep that to help improve the quality and improve the efficiency of our organization. In the software realm, everyone is in the procurement department, which says we have a massive amount of volume being downloaded, a massive amount of inefficiency, and a massive amount of variability that we need to manage, right? Now, you might not do this tomorrow, but something cool to do and like really strongly consider is go and block your access to the public repositories whether it's Docker Hub or Google Imagery or whatever, and only allow access through a proxy, through a repo, a private Docker registry or repository, what have you, right? So the developers actually should be happy because builds will run 10 or 20 times faster by doing this because you won't have to manage just the geographical distance between you and those repos, right? And you'll actually be able to see what's coming into your organization. The ability to audit what you're bringing into your organization when you have 4,000 people in procurement procuring what they want is absolutely impossible, right? There are organizations out there that have policies that say you need to go through approval to get these components approved if you ever want to use them in your organization. Those policies simply don't work. They were outgunned 10 years ago because the people using those or that set those policies up believe that you're consuming like 100 components a year, right? They don't realize the volume of what's coming into the organizations. And so, I'll shed a little light on that. All of you are familiar with DevOps, agile practices, lean practices, getting faster, higher velocity releases coming into an organization. And that is pressuring the organization to be more innovative and deliver faster. And these container technologies are helping to bring in and improve the innovation within those. So, not this year, but last year I did a survey of over 3,500 different developers, and I asked, does your organization have a policy for governing the quality of what's coming into your organization? So again, show of hands, how many think 25% of organizations, all sizes, have a policy to govern the quality of what comes in? You have an open source policy, you have some group that needs to evaluate what's coming in. B. C. 95%. That was the most show of hands. You're really optimistic, or you work at a really big company where they have lots of practices that they try and put in place. So 43% of organizations said they did not have an open source policy in place to govern anything about the quality or integrity or characteristics of those components, whether they were the licenses for those components, the security vulnerabilities, the age of those components coming into the organization. Hey, if it's 14 versions old, 9 years old, has known security flaws for 7 years, right? 43% of organizations don't even have a policy in place. And then, of course, I had to ask, if you have a policy in place, do you follow it? And 68% of those in the organizations actually follow those policies. And why doesn't everyone follow those policies? It's because they're slow, right? They need to, a developer wants to use something and they send off code for review to a review board that's going to take 2 weeks to respond to them, or some automated workflow process that's going to take a week to respond to them to tell them they can use the part. The developer is going to work around the process, if they even know what that is. And oh, by the way, I also ask, have you been breached by an open source vulnerability within your organization in the last 12 months? 1 in 10 said yes. They suspected an open source breach in the last 12 months in their organization. Now, I happened to be running this survey in April 2014 during the time that Heartbleed was announced. Remember, Heartbleed was around April 7th or 10th, 2014. We started the survey for a month on April 1st, went through April 30th. After Heartbleed was announced, 3 in 10 said they suspected a breach of open source. You had a question.
You answered it. I was curious what you meant by breach.
Yes. Okay. Super. So the effective rule is, if it doesn't fit, it doesn't get done. If your security policies or your quality policies are established in a way in your development lifecycle or in your release cycle that you're checking security before things are done and then creating unplanned rework for developers at the end of the process, then you're going to be very challenged in the volume of how things are happening today. So when you saw before that 240,000 components on average are downloaded by these organizations doing development, what I also saw in those numbers is 1 in 16 components that are downloaded from these public repositories have known security vulnerabilities in them. 1 in 16, which equates to about 15,000 electively bringing in known vulnerable components and using them in your software on a daily basis. If you didn't think that your software was vulnerable before this morning, right, after Christopher's talk, everyone got an inkling that they were more vulnerable. After this talk, if you're using any open source components, you have vulnerable software that's out there. And when I looked at this assessment, when I did this assessment, the one thing that I also saw which really scared me was the reports that I get are these huge spreadsheets that I had to look at. So if you downloaded 1 million things, I got a 1,000,000-line spreadsheet. And in that spreadsheet, I see the identifier of whether there was a CVE associated with that component that was downloaded or not. And so the CVE, you all know how it's identified. CVE dash 4 digits, which is the year, dash some ID number, right? And I would see pages and pages of CVE dash 2003 dash some identifier. CVE dash 2005 slash some identifier. So what that meant to me and what scared me about that was you're using a component, one, that's 12 years old. It couldn't have had a vulnerability in 2003 if it wasn't invented before 2003, right? So the component's at least 12 years old, right? The vulnerability is 12 years old within that component. And then the volume of the downloads was absolutely amazing. So I did a little research which showed me 66% of the components being downloaded had vulnerabilities that were known in 2013 or beyond. Heck, if they were just announced yesterday or last week or whatever, you might not have caught wind of that vulnerability. Your organization might not be as up to date, right? But when it's a couple of years old, it means you don't have a process to track or prevent these things from coming into your organization. Now, we also looked at the variety of things being downloaded. There was this kind of running joke within the organization. There was a major financial institution that downloaded 51 of the 58 versions available of Spring Core within a single year. So we said they were 7 away from perfect because they hadn't downloaded every single version within a year. So I looked at the top 100 component downloads of any organization and looked at the average number of versions that that organization consumed in 2014. So 27 different versions of every component that are out there. If you're like Google, right, you are managing one component, one version of every component that's available out there. Capital One, Topo, was at DevOps Enterprise Summit a couple weeks ago saying we have one version of every component that we use in our repo and only one version because it significantly reduces the complexity and variability within their organizations. How many of you would rather monitor and manage 100 parts versus 2,700 parts? Right? It's easier to manage 100 parts. Yes?
So do you have a sense for how many of those are downloaded because they're actually used in products, and how many are downloaded because somebody may actually be doing something very reasonable like performance testing, how something has changed from an old version to a new version?
Yeah, I don't.
That's a real significant difference. I mean, you're sort of implying that people are literally downloading old versions of software and using
Yes.
them as opposed to testing or analyzing code.
Yeah, so the question is, do we have any visibility as to where people are using them or if these are actually being used in new applications? I don't, right? So there can be different interpretations of this number, but what I did see was this was in a single year. This wasn't over the last 10 years people have downloaded 27 different versions. It's within a single calendar year, they're downloading this many versions, and they're doing it in extremely high volume, right? So that leads me to believe that there are developers that are out there, and I've talked to a lot of developers that are using a component because they've always used that component and that version of the component because it works, right? Versus there are, I'm absolutely positive, there are instances where people are doing performance testing or reliability testing using these old versions of components. So that will perhaps lower the number some, but I don't think it accounts for the difference between 100 and 2,700 being needed. But again, it's something to explore. So in the auto world, if you will, it's kind of like asking or telling a designer for the Land Rover, like you can pick any of 20 different mufflers that are available from 20 different years, and no matter if they have, known recalls in them, just put, whatever you want in the latest model year car that we're designing within our organization. So I mentioned Google, best-in-class operations, they are managing one version of a component. Capital One being another one that manages every version of components. The other thing that we're looking at, and we're hopefully in next year's research trying to get at, is how many duplicative types of components are organizations downloading. So when they did an analysis of healthcare.gov to find out where OpenSSL might be used within healthcare.gov, they found 11 different logging frameworks in healthcare.gov, where you could have used one of the best logging frameworks available, or even the best versions of that one available. So there's a huge variety of what's being consumed within these organizations that adds to this complexity. So one of the solutions that we also have, and maybe I have a link to it later, but we have a, yes?
How do you know which one's the best until you download it?
So there is, I'll just go on a very basic premise, right? There are 58 versions of Spring Core available. Version 1 is not as good as version 58, right? Because the open source project that is building this has figured out it was buggy, there's ways to improve performance, ways to improve features, what have you. So the latest versions are going to be better than the oldest versions, but that's something that needs to be investigated, or you need to get information and have that available to you to make those decisions. And I'm going to show you some evidence of what's happening to get you to that. Because finding the information now, if I tell you, hey, go out and research this, and it's going to take 6 hours to research every single component that you need within your organization, you're never going to do it. So what we found, we did an analysis of over 1,500 applications. We have a scanning tool. There are a lot of open source versions of this. Ours is free as well, that will tell you what components you have in your applications. On average, we saw an application has about 106 open source components in it. On average, we saw there were 23 known vulnerabilities in every app, across every app that, on average, that we looked at. Yes?
Suppose there's a 0.1 probability that updating a version breaks my code. Now you've got 106 of those.
Yeah.
I update everything to the latest version. There's very close to probability 1 that my code is broken.
Yes. That's true. But you're electively shipping known, bad, faulty parts in your products, right? So the trade-off is you're right, yeah. So I'm happy to address it, right? There's not, as I said at the beginning, there's not a perfect answer to what's going on here, but if we provide visibility to what's going on, we can think about how to improve it. No one wants their builds to be broken, right? But we do want to use the best quality parts in terms of what we're building into our products so that we don't get hacked, right? So that we do remain competitive. Because there are organizations, and big ones, like a GE, like a Disney, like a Bosch, like a Qualcomm, John Deere, eBay, the Federal Reserve, you name it, that are building the best quality parts into their software right now because they've recognized this kind of problem, right? So within those applications, I mentioned the number of known vulnerable components. I didn't mention there were also 9 restrictive GPL type licenses on average in each of those applications that we looked at. But none of you have one application in your organization, which amounts to a massive volume of technical debt and security debt that we've built up using these older versions, using these less secure versions, using versions that we're not obligated to use. But within the auto industry, getting back to the auto industry, we have lessons that we can learn, right? How many of you remember back in August, the Wired article where the reporter was sitting in the Grand Cherokee, driving it along some highway or interstate around St. Louis, I think it was, and the hackers hacked his vehicle and stopped him on the highway as the truck was approaching. Oh, crud, right? No one wants, I mean, I read the article and I still get shivers when I think about that happening, and the fact that they could not only do that to one Jeep, but every single Jeep on the road. And they had worked with Chrysler to figure this out. And within a week, if you remember, Chrysler ordered a recall. I don't know what it was, like a couple 100,000 or a couple million Jeeps that were on the road to say, there is a software update needed within these vehicles. And you know what the cool thing about that was? They knew every single part and every single version of every part in every vehicle that was shipped and who had it and how to communicate to them that they needed an update. You've got a bad version and it's time to update it because something went wrong. They have complete visibility across their entire supply chain to the part that they used, including their software. So an industry that we don't often think of as totally innovative has supply chain practices that we actually want to mimic in other parts of our organization. So in order to fix this, and this is shameless plug kind of stuff, so I don't want to spend a lot of time on it. But we believe that there is a way, if we are going to fix this, it doesn't get fixed in security review boards or open source review boards or some group that sits somewhere outside of development or operations, what have you. When you pick a component, we believe you should have information right when you pick that automatically says this is good or this is bad, this fits with our policy, you're intending to use this, it's approved to use immediately within your organization. If you have that as a developer, you will make the better choice to put the better component in from the start within your organization. If you can see the status of every build going through in your environment, the developers are using within your environment, you can make a better choice. If I can tell you that build had a security vulnerability or a GPL licensed component in it, or it produced a container with those in it, then you're less likely to deploy that later into production and have to fix it later. The other thing that we're wanting to address is putting together a bill of materials so that every single release that goes out the door, you are tracking what components were in that, just like Google was talking about. They know every single version of everything, including their build tools, that went into a release. So when something goes wrong, they have that bill of materials and they can instantly say, what do we need to reproduce this environment, or what was in that? Did we use that component somewhere that we need to fix within our organization. We know exactly where that is. So some of these practices about checking every build, empowering every developer, knowing what's in every build through a software bill of materials, we believe are some basic things that as an industry we can do and emphasize in our organizations to make the quality of what we're developing and releasing better. I will get to questions, but just quickly, if you want the slides, if you want the report, there's a 33-page report that details out a lot of this data. If you want the 2014 survey about the open source components and what have you, my out of office is on. If you email me right now, weeks@sonatype.com, you will get 3 links to all those slides. You will not be opted into some crazy marketing program that we're going to spam. Believe me, I'd like to answer each of you and say thank you for attending at the most, but you'll get a copy of everything that you need. You can download it quickly. And thank you. I'll take questions.
We have time for one question. Please come to the mic.
Is this? I assume you can hear me.
Yeah.
I'm curious because I saw your colleague talk yesterday and why you kept likening a GPL component to a security vulnerability. I feel like I know that your home is Apache. That's fine, but it struck me as kind of like irresponsible sort of scaremongering around the license of the components. And your colleague yesterday sort of alluded to that a little bit more too, and I just wanted to, am I reading that wrong, or?
No, so security vulnerabilities and GPL components are 2 totally different things, but they're risks that depending on what your organization is doing and where they're putting that software, there are different risks for that organization. So organizations that are like Qualcomm, if they're putting GPL license components into software that's going into chips, they're going to be sued, right? They don't want to do that. So they want to know.
Well, they're not necessarily going to be sued if they comply with the license.
Right. If they comply, if they knew that that was in there and if they were compliant.
Well, I mean, as long as you're shining a light and educating,
yes.
You know.
Yes.
It's.
Yes.
I mean, if we're all for people understanding and there being transparency, then
right.
I thought it felt irresponsible to me to keep lumping the 2 together as if they were similar.
Okay. I'll take that as good feedback.
Thank you.
So thank you very much. We're out of time. There will be conversation available in the hallway and also at the reception this evening, which I hope to see all of you at. Don't forget the BOF sessions tonight, and we'll see you all at tomorrow's opening session. Thank you very much and have a good evening.
Thank you.